Hey, what's up? Faizan here from Research Beast. On this channel, I share different tips and tricks for researchers, different motivational talks, and I also talk to experts about the research methods or anything related to research. So, if you're interested in content like this, please consider subscribing to the channel. Hello everybody, welcome to this video. This is another video on structural equation modeling using MPlus. Since these are a series of videos, if you're watching this video, I'd also recommend you to check out the playlist to watch the other videos. We have our very dear Dr. Rab Nawaz Lodhi from University of Central Punjab, who is a facilitator for this workshop. I've already introduced him in the first video of this series. He is an associate professor and he is a well-versed trainer for different software programs, including Smart PLS, and Vivo and MPlus. And he has done several workshops and trainings around the world in different countries. So thank you very much again, Dr. Lodhi, for giving your time. I know you're busy and I appreciate your time. And I'm pretty sure that whoever is watching this video would also appreciate your time. Thank you.
Thank you very much, Dr. Faizan. And dear audience, today we are going to discuss practically how to analyze the data, how to apply statistical modeling using MPlus software. So my name is Dr. Rab Nawaz Lodhi and this is my contact information. So I'm going to start practically this session about this statistical modeling. So I would like to introduce a very wonderful book. This is basically the Barbara's book, and the title of this book is Structure Equation Modeling with MPlus software. So,
Dr. Lodhi, I want to stop you here for 1 minute. I will put the link to this book in the description of the video. So you can check out the link if you are interested in getting this book. I'll be linking in the description for this book and several other books that can help you understanding structural equation modeling in general, as well as specific to MPlus.
thank you. Okay, now I would like to start that particular file on my desktop, data, and MPlus Dr. Faizan. So I have this particular data file, SPSS file. So I need to give these SPSS file, and we have 5 different variables. So I need to give the orientation about these variables. The first one is SQ. SQ means software quality or system quality. So these are the variables and constructs relating to Dillon-MacLean model of IS, information system success. So there are different constructs like system quality, information quality, and then uh, these variables are influencing the individual performance, IP, and then there is another variable that is organization performance, and here there is work group performance. So this particular model we are going to execute in MPlus software. This is the statistical modeling technique we are going to apply, and I need to give the orientation about these variables. So we have 5 variables. Just mind it and recall all these variable system quality, and we have 7 items of system quality, and then these are the 7 items of system quality, and these are the 7 items of information quality. These are the 6 items of individual performance. These are the 6 items, I think 6 items of worker performance. And similarly, these are the 6 items of the organizational performance, the last construct. So these are the 6 items of OP. OP means organizational performance. So what we are going to execute before execution of the model, we need to apply the different commands in MPlus software. So the first step you need to perform in MPlus software is to create or is to make the data file which will be acceptable in MPlus software. So MPlus software accept DAT file, dat file. So you need to save this file, and you need to check, you need to click files menu and then save as option. So I'm going to save this file in this particular folder data, then MPlus Dr. Faizan. So save, I'm going to change the extension and the type of this file. uh, this particular extension, this is acceptable in MPlus software tab delimited. So this is the DAT extension file. So you need to keep the three things in your mind. So what we are going to perform, we need to change the data type. We need to select the local encoding from the encoding menu. And you need to uncheck this particular write variable names to file, this particular option. So if you miss or any of the step, uh, any of these three steps, then definitely MPlus software will not accept that particular file. So then after providing these three informations, you need to give the title of this particular file. For example, if I'm going to execute statistical modeling, so I have saved this file with the title of SEM.dat file. So I need to click save, and software has created this DAT file. So now I have saved the file in Dr. Faizan MPlus folder. So now, after creating this particular file, you can also check the path of this particular file in the output of SPSS software. This is the path of, your data file. So after making this file, I'm going to run MPlus software. This is my MPlus software, MPlus editor 7, and now I need to create a new file. So I need to click file, then new. So this is basically the new file software has automatically created. Now I need to provide the different commands. There are two ways to provide the commands. Number one is to write all the commands. The commands I already discussed in my previous video. You can watch my previous video, the introduction of MPlus software, the different commands. And you will see that there are different commands. So you can write the different commands here in this particular area. And there is another way to provide the commands, which is MPlus language generator. So this is very wonderful facility in MPlus software. You can automatically generate the different commands. You don't need to write each and every command in MPlus software. So this is very simple. You need to click MPlus language generator and then SEM. For example, because this is the session of statistical modeling, we are going to apply statistical modeling. And in my next video, you will see the multi-level modeling like SEM with cluster data. So I will tell about this particular multi-level in our next video. So in this video, I'm going to discuss language generator, then statistical modeling. So you need to provide the title. For example, SEM, this is the title of my analysis, and then you need to provide the data file, where your file is located. So there are two ways. You can also provide manually, or you can provide by using this particular language generator. So I need to click browse, and then I need to locate my data file. So I have created the DAT file, which is acceptable in an MPlus software. So this is my data file, my SPSS file. But later on, I have converted this file into DAT format, which is acceptable in MPlus software. So I need to locate my file, open, and next. Okay, data format is free. Next, 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 next. Okay, the estimator is maximum likelihood estimators. After providing this particular information, then I need to click next. And what kind of output I'm expecting from MPlus software, I need to specify. So these are the output commands. So language generator will automatically generate the commands about modification indices. So I need to click this particular modification indices because we can also modify our model. So I'm going to give the minimum value, which is 10 in according to different statistician. So there is contradiction. Somebody say that this is the minimum value, 15 is acceptable, but someone say that 10 is fine. So then I need to click standardized coefficient, which is the very important value. So I don't need to click the model estimated mean, variance, covariance, and residual. But this is your choice. You can also, if you click this, software will provide the output regarding your command. So I can click this particular option, then estimate covariance or correlation matrices, estimate variance and covariance correlation matrices for the latent variable. So I need to check the correlation between the latent variable, between and among the latent variable. So these are the output commands. Software will automatically apply these commands according to my checklist. So I have provided the information in my checklist. Then
Hey guys, if you think you are getting some value out of this video, please do not forget to hit the like button and also subscribe to the channel. I would also appreciate if you can share this video within your social networks or within your networks of people that may need this video. Going back to the
then
video.
click next and finish. So this is very great. Software has automatically generated the different commands. So now what next I would like to mention here, and this is particular title. Title is SEM, file is software has also mentioned the path of that particular file, so variable. So I need to provide the further detail of this variable command, what kind of variable we are going to analyze in MPlus software. So I need to come back on my SPSS file. So here I have this particular option, variable list option. I need to click on this variable option. So these are the indicators. I need to select all, control A, and then paste. Okay. So in this particular syntax, software provided the names of all variables. I need to copy. Okay. I need to minimize. And then I need to paste because these are the variables we are going to use in MPlus software. So I need to provide the further details. Names are, these are the variable names are, these variables SQ1 to SQ7. So MPlus software does not like too many information in single line. So I need to break this particular line and then IQ, then IP, individual performance, then worker performance, and then organization performance. So I need to give the indication that I'm going to close this particular command. So this is the semicolon. And so after providing this particular command, you can watch in my previous video that in the PPT slides, I discussed that you need to provide the further extension of this command, which is use variable, use variables are. So use variable are mean if you're going to use only the last two variable, then you can mention only these two variable. It's mean you are not going to analyze in your software the first, second, third, and the first, second, and third. So these are the three variables you are going to ignore in your analysis part. So similarly, we apply this particular use variable while we are having the different demographic data, demographic information like gender, age, experience, level of income. So we apply this particular use variable command just to specify that we are going to use only the indicators for the further analysis. So now after providing this particular variable command, what we are going to do, we are going to apply the next command, which is model. So when I provide model, software is not case sensitive. You can provide the information in small letters or capital letters. This is your choice. So after providing this model command, I just put colon. Software understand that this is the command. It colors becomes blue. And now what I'm going to provide the model. So I just need to uh, because I'm going to analyze the all variables. So that's why I need to put all variables in my use variable command. So in my model command, I'm also going to put all variables like SQ, IQ, IP, WGP, and OP. So what kind of command I'm going to apply here? SQ by. Why by? By mean measurement model. So I need to put semicolon because this is the separate complete model, and then IQ by all these indicators from item 1 to item 7. Then the next one is IP by IP1 to IP6. Then WGP by WGP1 to WGP6. Then OP1 to OP by OP1 to OP6. So I have mentioned my measurement model. This is the measurement model I'm going to execute in MPlus software. So I have completed my all commands. This CFA we are going to execute, and this is the measurement model we are going to test. So after providing this particular detail, I'm going to save my data file. One thing you should keep in mind, if you are going to save your data file in the same folder where your data is already saved, so then there is no need to Dr. Fazan. So what next we are going to perform, I need to save this particular file in the same folder where I have already saved the data file. I need to use this file, then save, and this M plus Dr. Fazanali. So this is particular input file I'm going to create, M plus MP txt1, and the file extension will be INP file. So I need to save this particular file in the save folder. Now I need to run this particular command, run. Oh my goodness, that's great. Software has automatically created the output file. So mind it that this is the output file. This is not the input file. So the things are the similar. Whatever we have mentioned in the input file, these are all the things, because M plus software replicate all the commands, all the data, whatever you have mentioned in your input file. But this is actually the output file. So these are the input, but now we are going to discuss the output. These are the summary of the analysis, your latent variable, total latent variable, and this is the uh, model fit criteria. So these are the fit information, model fit information. So I'm going to discuss this chi-square value, and this chi-square value should be less than 3. So how we can calculate this particular value? We need to divide this particular chi-square value, like its value is 1248.702 divided by its degree of freedom. Degree of freedom is 454. So divided by 454. Its value is 2.7, which is less than 3. So this is acceptable. And now we are going to discuss, after discussing this chi-square value, RMC value, root mean square error of approximation. So its value is acceptable. Its value is less than the value. So this is the criteria that its value should be less between the range of 0.5 to zero point 0.1. So RMC value is acceptable and its probability value is less than 0.05 or even 0.01. So after discussing this particular model fit criteria, we are going to discuss the TLI value or the CFI value, comparative fit index, and the TLI value. So both the values should be near to zero point 0.9. So the values are 0.888 and 0.878, and both values are near to zero point 0.9. So both values are acceptable. So now after discussing this particular value, I'm going to discuss SRMR value, standardized root mean square residual. So its value should be less than zero point 0.05, or you can also mention that its value should be less than zero point 0.08. So you can give the range that if its value is 0, that would be the perfect fit. So its value is less than 0.05. So value is 0.046. So which is good for us in this particular model. So now there are different estimates, and this is the model results estimates, but these are the unstandardized uh, unstandardized loading values of system quality. These are the indicators, information quality. So these are the unstandardized. We do not use these unstandardized uh, loading values. I'm moving toward the standardized loading values. Please skip all these intercept of variances or residual variances. So we are looking for this particular standardized values. So you need to remember this STD YX. So these are the standardized model results. So here you can check that these are the loading values. So there are different criteria. Somebody say that more than zero point 0.6 value is acceptable, but now there are number of references that the loading value should be greater than zero point 0.7. So these are the loading values of different constructs, and similarly we can see that the loading values of system quality, information quality, individual performance, work group performance, and the last one is the organizational performance. So these are the loading values. So after discussing these loading values, uh, these are basically with mean covariance between the two uh, exogenous variables, because MPlus software supports the covariance-based attribution modeling. That's why it takes the covariance between the different pairs of exogenous variables. So these are the intercept, and but what next I'm going to show you the diagram, which is very important. So it will be very amazing diagram. So how we can execute the diagram? Please see this particular command, diagram, and then view diagram option. So this is very wonderful diagram. So here uh, this is particular the factor analysis, but one thing you should keep in mind, these are the unstandardized loading values. So we need to select this standardized loading value. How we can select? View and then STD YX estimates. So you need to select this particular option, and these are the standardized loading value. And don't be confused, these are not the uh, p values, probability value. These are the standard errors, SE, standard errors. So software will not show the p values or probability values along with the different standardized loading values. So now you can see that this particular uh, diagram, and the loading values and the covariance between the different constructs. So this is the measurement model. and CFA, and you can easily export this particular diagram file and then export to PDF. This is very simple. You can export it and you can later put in your research project. Okay, after discussing, but one thing which is very important for people, if you want to execute this diagram, you need to install Java program. So after installing Java program, this particular diagram option will be enabled. So these are the basically outputs along with the diagram. And now what I'm going to do, I'm going to close I'm going to close my output file. So I have closed my output file. This is my input file. But I'm going to change in this particular input file, I'm going to put the path model or the relationship model. So what I'm going to perform here, I need to give the commands like, for example, this is the particular model SQ, system quality, then information quality, then individual performance, then work group performance, and then last is organization performance. This is the path model, and according to this particular path model, I'm going to put the commands. So one by one, please look, and what I'm going to do, I have already mentioned the measurement model. Now I'm going to mention the relationship model. So the first one is IP, this one, IP. So IP on command is used for the regression. IP on the two variables SQ and IQ. So how we can mention here IP on SQ and IQ colon, semicolon. And then the next one is OP on the two variable. The first one is IP, the second one is WGP. So I need to put OP, IP, OP on, sorry, uh, IP and WGP, semicolon. And now I need to put this particular uh, WGP on IP. So this is the third path, WGP on IP semicolon. So I have completed my relationship model. Now I need to execute this model, run. I need to save it and run. Oh my goodness. This is my output file. So what I have extracted from this particular data, the remaining things are the same, like the chi-square value, RMC value, or the CFI value, TLI value, and SRMR values. So these are the standardized, sorry, unstandardized loading values. We are looking for the standardized loading values. YX. So these are the values, these are the loading values. But here we have already tested the measurement model. We are looking for the path model. So now I need to go for the path model. So this is IP on SQ and IQ. These are the beta values. So these are the beta values, these are the standard error, and this is these two values are the T statistics value. These two values are the P value. So now I need to put all these beta values. For example, SQ on IP, IP on SQ and IQ. So here these two beta values, I need to put 0.5, 4, 3 and 0.288. So how I can interpret my findings? If other factor remain constant, there is 1 unit change in IQ, it will increase IP by 288 units. So I can put the star to show the p-value which is significant. P-value is less than 0.001, so which is also favorable for me. So now I can put further OP on IP and GP. So these are the beta coefficient value 0.362, IP on OP 0.362, this is the beta value, and on a WGP on OP impact value is 0.560. Similarly, we have the last model, this particular model, IP and WGP. So value is 0.77772, which is also statistically significant. So all values are statistically significant values. So this is our path model, but we can also see the model, the particular path model. So where is the particular path model? Where is my diagram? Oh yes, this one, diagram, view diagram option. So this is very wonderful diagram. Okay, so the measurement model and the path models are the on the same time. You can check it, but here we need to check the standardized loading value. So STD YX estimates. So these are the standardized loading values. So these are the estimate. This is your choice. You can move the particular construct. You can also move the particular indicator of a particular construct. So this is flexibility, and these are the error, error term in covariance based attribution modeling. We also estimate the errors and also the covariance and also the errors of the covariance between the two constructs or two variables. So these are the beta coefficient values, this one and this one. So how we can interpret that? If other factor remain constant, there is 1 unit change in software quality or system quality, it will increase the individual performance by 0.543 units. So similarly, we can interpret the findings of information quality, the impact of information quality on individual performance. Similarly, we can interpret the impact of individual performance on worker performance. Its value is statistically significant. So please ignore this value because these are the standard error value. These are not the p value, probability value. So these are the standard error value. So you need to check this particular value, which is the beta value. So this particular beta value, if other factor remain constant, there is 1 unit change in work group performance, it will increase the organization performance by 0.56 units. So this is also the direct effect of individual performance on organization performance, which is also statistically significant. So this is all about the measurement model and the relationship model in MPlus software. But this is all about the statistical modeling. We have tested the measurement model. We also tested the path model. So we executed the model and we generated the different outputs along with the diagram. So audience, thank you very much for watching this video. So Dr. Faizan, thank you so much. And this is all about from my side.
Thank you, Dr. Lodhi. Again, it was a very wonderful tutorial, and I'm pretty sure that people would have got some value from it. Next video we will be doing would be about other issues related to M+. I think once we are done with this whole series of M+, maybe we can do a live session so that we can, answer some questions that people might have about M+.